Hello, my dear students. Let's get started with today's session. Today, we are going to learn and quickly revise the basic concepts related to the topic titled statistics. First, I shall cover the basic concepts and then in detail, we will be solving the problems. You need to by heart some formulae for solving some of the questions. While explaining those questions, I shall share those formulae, those shortcuts and all. So pay attention to the entire video lecture properly. Take notes whenever it is needed and make sure that you are learning these concepts thoroughly. Okay, so let's get started with this session. Students, in the first phase, I shall tell you how the various concepts or the various headings, I should say, they are organized. And this structure that I'm going to present in front of you, it will help you to get a clear understanding of this chapter. And also this will help you, this framework will help you to solve questions in a very effective way. Okay. So to start with, I shall consider something called as measures of central tendency. Okay, measures of central tendency. Okay, so measures of central tendency, when I consider, okay, there are two aspects in statistics that you have to consider. The first one is this measures of central tendency. Okay, so under this measures of central tendency, you should be learning about something called as mean, then median, and mode. Okay, so under this measures of central tendency, these 3 points will come: mean, median, and mode. And there is one more thing which you have to learn when it comes to statistics, that is measures of dispersion. Okay, and under this measures of dispersion, we will be focusing on the first one, that is range, and then we will be talking about quartile deviation. Then we will be talking about mean deviation. And then we will be talking about standard deviation. Okay. So this entire chapter that is related to statistics, when I consider, it has got two parts. The first part, I will say it is the measures of central tendency. The second part, it's about the measures of dispersion. Under measures of central tendency, we will be having 3 points here: mean, median, and mode. Under measures of dispersion, we will be talking about range, quartile deviation, mean deviation, and standard deviation. Now, under this title mean, we will be learning about arithmetic mean, geometric mean, harmonic mean. These three we have to consider. Okay. So this entire chapter on the statistics, when I consider, these are the various subheadings, I should say. Okay. So this is the, I should say, the framework based on which today's lecture, it is designed. Okay. So to start with, we will consider mean, and then we will talk about median, and then we will talk about mode. Okay. So mean. Let us consider two numbers, say A comma B. Okay. Now, the arithmetic mean associated with these two numbers A and B, it is calculated as a plus b upon 2. Okay. Geometric mean of two numbers a comma b, that is nothing but square root of ab. And harmonic mean associated with these two numbers a comma b, that will be 2ab upon a plus b. So when two numbers are under consideration, arithmetic mean will be a plus b by 2, geometric mean will be square root of ab, and harmonic mean it will be 2ab by a plus b. And always arithmetic mean will be greater than or equal to geometric mean. This will be greater than or equal to harmonic mean. Okay. So this is to start with, wherein I am considering two numbers a comma b. Okay. Now, in general, when we are considering where there are more than two observations, then I can say arithmetic mean, it is calculated as sum of all observations divided by number of observations. Okay. So this is the basic formula that you have to remember in order to calculate this arithmetic mean, sum of all observations by number of observations. Now, how about geometric mean? Suppose we are having some n observations. Let me say something like A1, A2, A3, A4, etc. up to AN. How will you calculate the geometric mean of these observations? Please be aware, the geometric mean of these observations will be the nth root of A1 into A2 into A3 into etc. up to AN. Okay. So you will take the product of all these observations and then you take its nth root. So that is how you will be calculating the geometric mean. Okay. And when we are having some n observations, to calculate the harmonic mean, the formula that you have to consider, it will be n divided by, observe it closely, n divided by 1 by A1 plus 1 by A2 plus 1 by A3 plus etc. up to 1 by AN. Okay. So to start with, arithmetic mean, geometric mean, harmonic mean, what it is all about, the main formulae, I have given you an idea. Okay. Now, related to the, when I consider the structured approach, as I told you, under measures of central tendency, mean is there, the three mean we have considered. Okay, AM, GM, and HM. And please be aware of this, AM greater than or equal to GM, which will be greater than or equal to HM. Okay. And also, we can consider geometric mean square. This will be equal to arithmetic mean into harmonic mean. Okay. So this is another observation which you can consider for solving some of the questions today. Okay. So make a note of these details. Now, under measures of central tendency, we have just finished the mean part. Now, we need to focus on something called as median, and also we need to focus on something called as mode. Okay. What is this median all about? Median is nothing but that observation which is located exactly in the middle, exactly in the center, when you are arranging all the observations either in the ascending order or in the descending order. Okay, for example, let me say that there are 7 observations. Those 7 observations in the ascending order, when I am writing it, it is A, B, C, D, E, F, G. Okay, I am writing them in the ascending order, in the increasing order. Okay, so there are 7 observations. So the number of observations is equal to 7 here. So you just perform 7 plus 1 divided by 2. That is equal to 4, right? So after writing these observations in the ascending order, you locate which is that fourth observation. The fourth observation you can see that is D, which I have written here. I don't know what value it is, but that fourth observation, which is located exactly in the middle, that is going to be the median. Got the point? So this way, by arranging those observations in the ascending order or in the descending order, whichever that you are comfortable with, sort it correctly, and then locate that middle observation. If the number of observations it is odd, just to do plus 1 by 2. Here it is 7 plus 1 8 by 2 4. The fourth observation will be located exactly in the center. I repeat, the first thing is you have to arrange these observations in the ascending or descending order. Then you can see that, say here, as there are 7 observations, right? To the left side of median, there are 3 observations. To the right side of median also, you have got 3 observations. Okay, so make a note of this point. Now there may be a doubt. What will be the case if the number of observations, say, that is equal to even? Let me consider something like A, B, C, D, E, F. The number of observations, you can say it is equal to 6 here. So how are you going to locate the middle observation, the central observation? So the first thing is make sure that these numbers, observations, are arranged in the ascending or in the descending order. Okay. So after that, if the number of observations, if it is even, just to perform n by 2, and you take the next observation also. Okay, here 6, right? So you take half of 6. What is half of 6? It is equal to 3, right? So look at the third observation and then look at the fourth observation. And you take the arithmetic mean of these two observations. Okay, that is how you are locating the median associated with A, B, C, D, E, F. So first you arrange them in the ascending order or in the descending order. If the number of observations, if it is even, just you find out the n by 2th observation and the next observation. Here, 6 observations are there. 6 by 2 is 3. You locate the third observation and the fourth observation. After arranging all these observations in the ascending or in the descending order, you just take the arithmetic mean of these two observations. That is going to get you the median. Okay. Mod, it is very easy. You look at all the observations and locate which is that observation which has appeared with maximum frequency. Okay, so the observation which has appeared, okay, maximum number of times. Okay, that is nothing but the mod. Okay, so make a note of this as well. Median, which is a central observation, mod. It is nothing but that observation, the given set of observations, that observation which has appeared maximum number of times, which has repeated maximum number of times, that is going to be the mod. And there is an empirical formula that connects the mean, median, and mod, which you must remember. Take it down. Mod, this will be equal to 3 times median minus 2 times mean. Okay, just by knowing this formula, you will be able to answer questions very easily. 2 times mean. Okay, this is an important result, and that is what we are quickly considering in this lecture. Okay, so make a note of this. Mod is equal to 3 median minus 2 mean. So sometimes, in the question, mod will be given and mean will be given. You may be asked to find out what is median. Or mod and median will be given. You may be asked to find what is mean. Okay, so 2 will be there, 1 will be missing. You will be asked to calculate that. Okay, so for that, knowing this formula is very important, and that's what I have presented. Okay, so under measures of central tendency, mean, median, and mod, I have explained to you quickly what each corresponds to and the important formulae. So with this, we will start with the first question for the day. Take a look at this question. You are asked to find the arithmetic mean of 4 square, 5 square, 6 square, 7 square, 8 square, 9 square. So we can see that the number of observations here, it is equal to 6, right? 4 square, 5 square, 6 square, 7 square, 8 square, 9 square. You are asked to find the arithmetic mean. So one way is you can find out what is 4 square. You can consider what is 5 square, what is 6 square, what is 7 square, what is 8 square, what is 9 square. You add everything together, you will get the sum of observation. Then that sum of observation by number of observation, when you do, you will be getting the arithmetic mean. That is one way you can calculate this. Another way, you can do this question will be recall summation n square, sum of squares of first n natural numbers. It is n into n plus 1 into 2n plus 1 whole divided by 6. Okay, so what you are going to do here is you will consider finding what is this 1 square plus 2 square plus 3 square plus 4 square plus etc. up to 9 square. That is the sum of squares of first 9 natural numbers. That will be 9 into 9 plus 1, 10 into 2n plus 1. 2 into 9, 18. 18 plus 1, 19. Whole divided by 6. Okay, so first you calculate what is this value. And then from this, you remove this 1 square, 2 square, and 3 square. Okay, so from that total, what you just calculated, you just exclude this 1 square plus 2 square plus 3 square. That you can do it easily. 3 square is 9, 2 square is 4, and 1 square is 1. You can see that total will come as 14. So from this, you exclude that 14. That will get you what is the value associated with this 4 square, 5 square, 6 square, 7 square, 8 square, and 9 square. That sum of all the observations, you will get it that way. So 9 into 10 into 19 whole divided by 6 when I do. Okay, that is sum of squares of the first 9 natural numbers when you do. You can see this results in the value that is equal to 285. Okay, this value, it will be equal to 285. So from 285, you exclude that 1 square plus 2 square plus 3 square. That is, you exclude that 40. Now you are getting sum of all the observations. That is 4 square, 5 square, 6 square, 7 square, 8 square, and 9 square. You get this total. Okay. That sum of observation by number of observations, it is equal to 6. So this is basically 285 minus 14 divided by 6, which is 271 divided by 6. And I can say this value will be 45.16. Looking at the answer choices here, I can say option D, it reads 45.16, and that is going to be my answer as far as this question it is concerned. Now, please note one more thing. Here, you are dealing with small set of numbers only, up to 9 square and on. But just imagine, suppose you are given something like find the arithmetic mean of 1 square plus 2, find the arithmetic mean of something like 12 square plus 13 square plus 14 square plus 15 square plus like that. Okay, somewhere over there if it starts. Then the same logic what I have presented here, okay, you can actually consider it. Okay, so make a note of this. Here the answer will be coming as 45.16. Let's go ahead with the next question. You are asked to find the arithmetic mean of 4, 16, 64, etc. up to 4096. So you can see that here, this is a clear-cut geometric progression. Okay, 4 fours are 16, 16 fours are 64. Like that, it is proceeding up to 4096. If I am listing the further numbers, I can see that 64 into 4, which is 256, 256 into 4, which is 1025, 1024. Okay, I'm just multiplying everything with 4. Okay, 4 into 4, 16, into 4, 64, into 4, 256, into 4, 1024, into 4, that is 4096. So these are the numbers involved, right? So you can see that the number of observations, it is equal to 6 in this case. Okay, you are asked to find the arithmetic mean of these 6 numbers only. So what is that arithmetic mean? Sum of all the observations divided by number of observations. So one way is you can sit and add 4096 plus 1024 plus 256 plus 64 plus 16 plus 4. You can get the total, and then that total, it will come here as 5460. Okay, if you are quick in adding all these, you can say this will total will come here as 5460. Divide this guy with 6, because number of observations, it is equal to 6, and that will fetch you the number 910. So sum of observation by number of observation, that is the arithmetic mean, it will come here as 910. Okay, this is one way we can answer the question. Another way also I shall explain. Here we have got 6 terms, right? So if you can consider sum to n terms of a geometric progression, which is a into r power n minus 1 divided by r minus 1. So here a, it is 4. 4 into, the common ratio is also 4. 4 power 6 minus 1 divided by r minus 1. R is 4. So 4 minus 1, you can say that is equal to 3. So upon further calculation, it is 4 into 4 power 6 is 2 power 12. That is nothing but 4096. Okay, decrement it by 1. My mistake. 4 into 4096 minus 1 whole divided by 3. This way also you can do. And either way around, you can see that the sum to n terms, it will come here as 5460. When you're going to solve it, you can say this will be coming here as 5460. Okay, that value divided by 6, the number of observations when you do, you will be getting the arithmetic mean. That will come here as 910. Okay, so please make a note of the same. This is for our second question. Okay, if the numbers are small, 2 lesson number, or the numbers under consideration, the total numbers of numbers that is under consideration, if it is too small, then you can manually add them or multiply them and get the results. But if the numbers are relatively, the number of numbers that you are handling, they are bigger, then these formulae what I have presented, okay, that is Sn is equal to a into r power n minus 1 by r minus 1. This formula I have presented, right? So this will be helpful for you to do those calculations faster. Okay, so that brings conclusion to the second question. Let's move on to the third one. You're asked to find the arithmetic mean of 9, 17, 25, 33, etc. And the last number, it is 105. If you observe somewhat closely, you can see that these numbers 9, 17, 25, 33, they are in arithmetic progression, because 9 plus 8, it is equal to 17. 17 plus 8, that is 25, plus 8, that is 33, so on and so forth. Okay, so you know that these numbers that are presented, they are in arithmetic progression. Now please note, if these numbers, they are in arithmetic progression, then arithmetic mean of numbers in arithmetic progression, that is nothing but the last term plus first term divided by 2. It is going to be the arithmetic mean of 105 plus 9 divided by 2. Okay, here you can see the common difference. It is coming as 8. 9 plus 8 is 17. Plus 8 is 25. Plus 8 is 33. So you have a 105 here, 105 plus 9, that is equal to 114. So 114 divided by 2 when you do, you will get the result here as 57. Okay, so for this question, you need not find what is the total of 9, 17, 25, etc. Then talk about what is the number of terms. Nothing needed there. Okay, it's just a matter of you doing the calculation last term plus first term divided by 2. Okay, you can see here another interesting observation. You have 105 here, right? The common difference I told you, it is equal to 8. So prior to this 105, the number it would have been 97. And here you have 105. Got it? So you can see that this penultimate term, that is 97, and this 17 if you are adding, still the total will be 140. Okay. The term prior to 97, that is 89. That 89 plus 25 when you add, still the total will be 114. So that trend you should have an idea. Somewhere down the line, you will be finding it useful. Okay. So the total, when you are considering last term plus first term whole divided by 2, you can do. That will fetch the answer here as 57. And that brings conclusion to our third question. Okay. Option C, 57 is our answer. Okay. Let's now consider the next question. It is given the arithmetic mean of a set of numbers, set of 50 numbers is 42. So please note, arithmetic mean, it is equal to sum of observations divided by number of observations, right? So here in the first case, the first part of the question when we are considering, the arithmetic mean of a set of 50 numbers is 42. So the number of observations, it is 50. The arithmetic mean, it is equal to 42. So from this, I can find out the sum of all those 50 numbers. What will be that? Sum is equal to average into number of observations. That will be 42 into 50, it will come. Okay, what is that 42 into 50? That is equal to 2100. So this is the total. Okay, when you are considering, I have mentioned the arithmetic mean of a set of 50 numbers is equal to 42 when they say the sum of all those 50 numbers under consideration, it will be average into number of observation 2100. Okay, so sum of observations you got. Now what is happening? From this, two numbers 75 and 105, they are discarded. What does that mean? It means that the 75 and this 105, they are eliminated. So when you do that, you can see the number of observations. I shall write it as n dash. That is going to be equal to 48 because from 50 observations, you are removing 2. So 50 minus 2, 48 observations are there. The sum of observations, that is sum of all those 48 numbers, that will be nothing but 2100 minus 75 and also minus 105. Got it? So those two numbers you are excluding. And that results in the new sum of observations that is coming here as 2100 minus 75 minus 105. That is equal to 1920. So this is the revised sum of observations. Okay. Now you are asked to find the arithmetic mean of these remaining set of numbers. What is that arithmetic mean? Sum of observations upon number of observations. 50 minus 2, it is 48. So that fetch you the revised arithmetic mean. And how much will be the value? 1920 minus 2100 minus 75 minus 105, that is 1920. 1920 by 48 when you do, you will get the number here as 40. Okay, so the arithmetic mean of that remaining set, option A, 40, that is going to be our answer. Okay. Let's consider the next question. Take a look at this. The arithmetic mean of a set of 7 observations is 36 and that of another set of 13 observations is 46. So there is a set 1 number of observations and set 2 number of observations. So when I am considering the number of observations in set 1, you can see that it is 7. In set 2, it is equal to 13. The arithmetic mean of set 1 observations, it is 36. The arithmetic mean of set 2 observations, it is given as 46. So with the help of these two, I can find the sum of all observations. Okay, sum of all observations. That will be 7 into 36 here, and that will be 13 into 46 here. Okay, so the total number of observations, okay, the number of observations total, you know how much it will be? That will be equal to this 7 over here and this 13 over here. 7 plus 13, you know, that is equal to 20. Now look at the question. They are asking you the mean of the combined set. They are basically asking you to find what is the weighted average and how much it will come. In this case, the weighted average will come as 7 into 36 plus 13 into 46 whole divided by 20. The total number of observations, that is equal to 20. It comes like this. Okay. So when you are simplifying it, okay, I have completed the calculations here. When I am simplifying it, 7 into 36 plus 13 into 46 whole divided by 20, when you do, you will get the result here as 42.5. Looking at the answer choices here, option B, it reads 42.5. That will be my answer. Okay. Now, the general formula for these types of questions. So there is a group 1, N1 observations are there. Let the average be A1. There is another group 2, N2 observations are there. Let the average be A2. Now, the combined average, you know what that will be? The combined average will be N1 A1 plus N2 A2 whole divided by N1 plus N2. Okay, sum of all observations divided by total number of observations. That is the combined average. We also call it as the concepts on this weighted average. Okay, so both are equally important. Just be familiar with the terms. Here, 42.5. Option B reads 42.5. That is my answer. And that brings conclusion to our question number 5. Now, let us consider the next question here. You are asked to find the harmonic mean of 1, 1 by 4, 1 by 7, 1 by 8, 1 by 10. So you can see here, altogether there are 1, 2, 3, 4, 5. 5 observations are there. So let me do one thing. Instead of taking that 1, 1 by 4, 1 by 7, 1 by 10, 1 by 10, 1 by 8 and all, let me take those 5 observations as A, comma, B, comma, C, comma, D, comma, E. Okay, the harmonic mean of these 5 observations, you know, it will be 5 divided by 1 by A plus 1 by B plus 1 by C plus 1 by D plus 1 by E. So this is the basic formula that I am going to use here for finding the harmonic mean of these set of observations. So how to calculate it? I can consider this harmonic mean here. It will be 5 upon, first observation is 1. So you can take it as 1 by 1, which is equal to 1. The second observation B, it is 1 by 4. You have to find 1 by B, right? So 1 by 1 by 4. That is nothing but 4 by 1. Similarly, 1 by 7, its reciprocal when you take, it will become 7 by 1. Okay, then you have 8 by 1, and then you have 10 by 1. Got it? So the same thing which I gave you the formula, n by 1 by a plus 1 by b, like that when you are doing, this is how it will look like. So this is as good as 5 divided by 1 plus 4 plus 7 plus 8 plus 10. Okay, so let us try to add them quickly. This is 10. 8 plus 7, you know that is 15. 15 plus 5, it is 20. So this 20 plus this 10. You know the total will come as 30. So here we have 5 divided by 30 that comes, and that is equal to 1 by 6. Okay, so we can see that here the result it comes here as 1 upon 6. That will be the harmonic mean. Going by the options, we can see option B, it reads 1 by 5, and that is equal to our answer. Okay. And that brings conclusion to our question number 6 in the log. Let's now consider the next one, the seventh question. You are asked to find the geometric mean of 3 power 1, 3 power 2, 3 power 3, etc. 3 power 99. So there are altogether 99 terms here. So as per the rule, you have to find the 99th root of 3 power 1 into 3 power 2 into 3 power 3 into 3 power 4, etc. up to 3 power 99. But that is going to be a tedious task. But if I observe this 3 power 1, 3 power 2, 3 power 3, etc. up to 3 power 99, if I take, you can see that all these terms, they are forming a geometric progression here. So the theory, the shortcut way of doing this question is geometric mean of numbers in geometric progression. You know, that will be nothing but square root of the last term and the first term. This is more than sufficient. So this is the shortcut which you have to use. Okay. So please note, if the given numbers, you know, they are in geometric progression, in order to find the geometric mean, it is sufficient you take the square root of the product of the last term and the first term. And here, when I'm going to apply that result, the geometric mean, you know, it will be nothing but square root of 3 power 1, that is the first term, and 3 power 99, that is the last term. And that is equal to square root of 3 power 1 into 3 power 99, you know, it is 3 power 100, and that is equal to 3 power 50, it comes. Okay. Square root of 3 power 100 is 3 power 50. Let me look at the options. Okay, it's quite weird to say there is no 3 power 50. But you know that this is nothing but the same thing, what you see here, 3 power 50. It is nothing but 3 power 2, the whole raised to 25. That is, it is as good as 9 power 25. Please check whether 9 power 25 is there. Yes. Option C, it reads 9 power 25. It is there. So as far as this question it is concerned, option C, 9 power 25, it is going to be my answer. So the main take home by considering this question, it is that if the numbers are in geometric progression, you can use this result in order to find the geometric mean. Okay. Now, let's consider the next question. You are asked to find the median of these given set of observations. So the number of observations when I am considering, you know, it's equal to 1, 2, 3, 4, 5, 6, 7. Altogether, there are 7 observations. So median will be nothing but 7 plus 1, 8 by 2. The fourth observation, when I am arranging these given observations in the ascending or in the descending order, which is that fourth observation I have to find out. That fourth observation, it is going to be the median of these set of observations. Okay, so when I am observing here, I can see that this is going to be the smallest number. Okay, so 1.2413, the smallest number I have presented. Okay, now the next bigger number, it is 15.3125. This is the next bigger number. Okay, I'm writing it in the ascending order. Okay, now the next one, I'll just highlight it. You can say 15.3125. I have taken that. Okay, the next bigger number is 15.3142, and we have 15.3143. Okay, so those two numbers I am going to consider. Okay, please observe 15.3142 and we have 15.3143. Okay, now please observe there are altogether, see, I'm highlighting it, okay, 3142 here and 3143 here. The remaining three, you can see that 15.5213, 15.4132, 15.3215, those three observations, they are going to be on the right hand side of this 15.3143. So you need not write it, because when the number of observations, it is 7. 7 plus 1, 8 by 2, it is equal to 4. The fourth observation itself will be the median. And you can see that here, that fourth observation is 15.3143. You saw that? So we can see that this 15.3143 itself, it is the median. So you can use your, I should say, your mathematical or observation skills to locate that fourth number correctly, and that is coming as 15.3143. That is going to be our answer here. All right. I guess these explanations are clear to you. 15.3143 is the answer for this 8th question. Okay. Now let us consider the next question. You are asked to find the median of 15, 22, 8, 6, 16, 20, 14, and 4. If I am observing here the number of observations, 1, 2, 3, 4, 5, 6, 7, 8. 8 observations are there. Okay, so 8 by 2. The fourth observation, you look at what it is after arranging them in the ascending or in the descending order. Fourth observation and the fifth observation you consider and you take its arithmetic mean. So if I'm going by the ascending order concept, okay, so the smallest number, that is equal to 4. So write it first. The next bigger number, that is 6, and then comes 8. So 6, then comes 8. Okay. And after that, we can consider that 14 is there. We can consider that 15 is there. So write 40, write 15. As I told you, we can actually stop writing the numbers over here, because remaining, when you consider, it is 16, 20, and 22. You want, you can write 16, 20, 22. You want, you can write. Otherwise, it's up to this point, it is more than sufficient, because 8 observation means I want to know the fourth observation. I want to know the fifth observation. I just want to find the arithmetic mean of those 14 and 15. And that will get me the median. Because here the number of observations, it is even. So n by 2 observation and n by 2 plus 1, that observation, I need to locate them after arranging the given set of observations in the ascending order or in the descending order. Once I am ready with those, you just take the arithmetic mean of them. That's all. So here you can say 14 and 15 are there. The arithmetic mean of our 14, 15, that is equal to 14.5 And you can see that is going to be the median of this given set of observations. Option C, that is 14.5, that is going to be the answer here. Okay. So that brings conclusion to our question number 9 in this lot. Let us consider the next question. You are asked to find the median of the first 17 prime numbers. Again, median. Number of observations, 17. 17 is an odd number. So just do 17 plus 1, 18 by 2, 9. I can see that the 9th prime number, okay, that is going to be the median. So now the 9th prime number, see 2, 3, 5, 7, 8, 9, 10, they are not prime. Then we have 11, we have 13, then we have 17, we have 19, then 20 not there, 21 not there, 22 not there, we have 23. And when I'm observing, you can say 1, 2, 3, 4, 5, 6, 7, 8, 9. That 9th prime number, you can say it is equal to 23. So for this particular question, option D, it reads 23. That is going to be my answer. Okay. So you must also be aware of the fact that from 1 to 100, if you are considering, there are altogether 25 prime numbers. Okay. So now you can even expect a question like this. Considering all the prime numbers from 1 to 100, what is the median value of that prime numbers? Okay, from 1 to 100. So that's why I said in the beginning, considering all the prime numbers from 1 to 100, what is the median value of that set of observations? So what you will do, you know that 1 to 100, there are 25 prime numbers. 25 is odd. So 25 plus 1, 26 by 2. The 13th prime number from the beginning when you consider, that will be my answer. Okay. Calculation, I'm leaving it to you. After 23, you can say 24, 25, 26, 27, 28 won't be there. 29 will be there. Okay. 31 will be there. Like that it goes. So you can locate what is that associated with that 13th prime number. You can calculate it. But I gave you the idea. Okay. You don't actually need to write all the observations. That middle one, whatever that it is, that is what you have to find out. Okay. So here for our question, you can see that I need to focus on that 9th prime number, which is 23. So 23 is my final answer. Option D is what I should choose. Okay. So that brings conclusion to our question number 10. Let's now go to the 11th one. Look at this. The median of a series of 17 numbers is 23. See, the number of observations, you can consider that it is equal to 17. Listen carefully. 17 means what? 17 plus 1, 18, 18 by 2. The 9th observation, okay, that is nothing but the median value. That 9th observation, it is equal to 23, which means there are 8 numbers to the left and there are 8 numbers to the right of this 23. So you can see that 8 plus 8, 16 plus the middle wala 23 put together, you can see that the number of observations is coming as 17. I repeat, 8 plus 8, 16 plus this solo 17 observations. It comes and that is 23. Now what is happening? You can see that 2 more numbers, 20 and 27 are included to this set. 20, you know, it will definitely come to the left side of our 23 when I am arranging the numbers in the ascending order. 27 will be coming here to the right side of 23. Again, I am presenting the numbers in the ascending order. So you can see that here the the 23, what you see there, it still continues to be in the middle position. Okay, because you added one to the left and one to the right. Okay, so you can see the number of observations, it has become 19. Got it? So I can see that the 10th observation, it will be coming in the median position. And yes, that is happening. Okay, you can see that here, there are altogether 9 observations to the left. You can see that there are altogether 9 observations to the right. Okay, 9 plus 9, 18, plus this, that is equal to 19. 9 plus 9, 18, plus this single observation, solo observation. I can see that is resulting in altogether 19 observations. And that is what it happens. To the 70, you are adding 2 more, right? So number of observations, it is becoming 19. Got it? So you can see that here, the 10th observation, it thus comes in the center. It tallies now. See, 10th observation, 9 are there to the left and 9 are there to the right. 9 plus 9, 18, plus this guy. That is equal to 19. To the 17 observations, you are adding 2 of them. You can see that the position of the median is actually not changing. The 23 still remains as the middle observation, the central observation. So the median of this entire set, when you consider, I can say that is equal to still 23. Okay, but such a situation is not possible for us to consider when both the numbers are less than 23 or both the numbers are more than 23. If that comes, then the position of that median can get shifted. So as we don't have a clarity on the numbers altogether that are there that we are handling, so the answer will then become cannot be determined. But here, the biggest advantage is that 23 is in the middle, 20 is one, it is less than 23, and 27 is another one which is greater than 23. So the median will still remain the same as 23. The position won't change. Okay, so that brings conclusion to our question number 11. Let us now go to the next one. This is an amazing question. Okay, just have a look at this. Find the range of values that the median can take for this given series. So there is a value x that is coming there. About x, I don't have a clarity, but all other numbers, I have a clarity. So let me present them in the ascending order. 5 I have considered. So let me highlight it. The next bigger number in the lot, that is 7. So let me highlight it. After that, you can see that we have a 12. So I shall write 12 here and let me highlight it. And then you have 14. Let me highlight it. And then you can see there is a 16 and there is an 18. Okay, so I'm writing 16 here. I'm writing 18 here. And then let me consider that x, it is located over here at the extreme right end. That is the largest value. Let me put it in that way. So the number of observations is 1, 2, 3, 4, 5, 6, 7. 7 observations are there. So median means what? 7 plus 1, 8 by 2, 4. The fourth observation will be the median. 1, 2, 3, 4. I can see that here, in this case, you can see that the median, it is the fourth observation, and I can see that is equal to 14. Got the point? Now, the same case, anywhere to the right side of 14, you are placing this x. Okay, you can place that x. I'm just erasing it. Okay, just imagine I'm just erasing that x. Okay, that if I am placing it here, or I am placing it here, or I am placing it here, you can see that the number of observations to the right side of 14 will be 3. The left side of 14 will also be 3. 14 will be located exactly as the median. See this, if I place x here, 3 observations are there to the right side of 14. If I place x here, again 16x, 18, it will come, 3 are there. If I place x here, 16, 18x. Okay, that unknown. 3 are there. So still 14 continues to be there in the median position. You got my point? Now in the same way, consider that x is located over here. Okay, left end. So we can see that here 1, 2, 3, 4, 5, 6, 7. Altogether 7 observations are there. So the fourth observation is going to be the median. See this 1, 2, 3, 4. The fourth observation is 12. Okay, so you can see that in this case, the median, it is equal to 12. Okay, and in the same way, just like I explained, wherever you are placing that x to the left side of 12, you can place it here, you can place it here, or you can place it here as well. You can see that still 12 continues to be there in the median. Okay, now just imagine, suppose I am going to place that x in between this 12 and 14. Okay, and suppose I'm going to place it over here. Then you can see that in that case, the median value, it will become equal to x. Did you get me? The median, it will become equal to x. See this, I am placing it in between that 12 and 14. So x is here, 3 to the left, x is here, 3 to the right. So x can become the median also. So in the question it is asked, find the range of values that median can take. So it is now evident that this median, it will be this inequality. What I am writing here, you can say this will serve the purpose. It can take set of values between 12 to 40. It could be 12, it could be 40, or any value in between the 12 and 40. Got my point? So you can see here, option B, it reads 12, 14 with that square bracket over there, which means 12 and also 14 can be considered. So option B, it is going to be my answer. Okay, so it's a very interesting question. The range of value, it is what they have asked you. So don't start with that unknown. You please start with the known numbers, arrange them in the ascending or in the descending order, and then you try to place that x and see how the values they are changing. Okay, so option B will be our answer choice, and we have just completed question number 12. Okay, let's now consider the next question, the 13th one. Find the mode of the following set of observations: 4, 8, 10, 10, 10, 8, 10, x, 5. So you can see 10, it appears 4 times. Okay, even if the x is coming only once. See, mod means what? Mod is referring to the number that actually, or mod is referring to that observation that has actually applied multiple number of times. That observation that has appeared maximum number of times. Okay, so I'm correcting what I just said. Mod is nothing but that observation that has appeared maximum number of times. Okay, so you can see here 10 has actually appeared 1, 2, 3, 4. 4 times it has come. So we can see that the answer, the mod value, it will be equal to option B, that is 10. Okay, so we can consider the 13th question. The correct answer, it is option B. Observation that repeats maximum number of times, that is nothing but mod. 10 is repeating 4 times, so that is the mod here. Okay, now let us consider the next question. This is the 14th question in this lot. It is given that here the mean and the median of a distribution are 1.25 and 4.5 respectively. The question is, what is the mod value? So please note, the formula is mod, it is equal to 3 times median minus 2 times mean. Okay, so if you remember this formula, there you go, you just substitute the value and close the question. But if you don't know that formula, better you leave that question. Okay, so we have 3 times the median, it is equal to 4.5. Please be careful here. The mean is 1.25. Okay. So 3 times median minus 2 times the mean, it is 1.25. So when I am calculating it, you can say 3 times 4.5. I can see that 4 3s are 12. 3 into 0.5 is 1.5. So this will come as 13.5 minus 2 into 1.5, it is equal to 2.5. So when I am doing the calculation, I can say my answer, the mod value, it will be coming here as 11. So for this question, the final answer, it is equal to 11. Mod is equal to 11. Okay, so make a note of that. We have just completed question number 14. Let's move on. 15th question. The range of the set S that consists of x1, x2, x3, x4, etc. up to xn, the range is R. They're asking you, find the range of a set where the observations, each and every observation, you have incremented it by 4. Okay, you can see every observation, you can say you have incremented it by 4. So what is the range? See, range of a set of observation, it's nothing but the maximum value minus the minimum value. Listen carefully. Range is nothing but the maximum value which is there in the set of observation minus the minimum value there in the set of observations. Okay. So either you are adding or subtracting a constant to the existing set of observations. Please be aware that the range, it is not going to change. The range, it will remain the same only. Okay. So I repeat, on adding or subtracting a constant on that given set of observations, please be aware the range is not going to get affected. Okay. If you want to have a proof, I shall just consider, say, the numbers like 2, 4, 6, 8, 10. Here you can see the maximum value is 10, the minimum value it is 2. You can see that max minus min, 10 minus 2, you can see that this is 8. Let me say each number, it is incremented by 5. So 2 plus 5, it is 7. 4 plus 5, it is 9. 6 plus 5, it is 11. Then it is 13. Then this is 15. You can see the range here, it will be 15 minus 7. Still, it is remaining as 8 only. This is what I was telling you earlier. Okay, even if the numbers are jumbled, sorted, whatever, maximum number minus minimum number is nothing but the range. Okay, so you can see that when you are adding or subtracting a constant term or a constant number in the given set of observations, the range is not going to get affected at all. So it is given in the question that for this first set, the range is R. So for this set also, the range value, it will be R. So for this question, option D, it reads R. That is going to be my answer. Okay. So please be aware, we have just completed question number 15. Okay. Now, in this measures of dispersion, there is something called as quartile deviation. And that is what in the next question we are quickly going to consider. It is given 15, 9, 10, 13, 6, 13, 16, 5 and 20. The step 1, it is equal to, or the step 1 is nothing but arrange these observations either in the ascending order or in the descending order. Okay, so I'm going ahead with considering the numbers in the ascending order. So the smallest in the lot, it is 5. Then the next bigger number, it is 9. After that, we have a 10 here. Then I can see that there is a 13. I can see there is a 15 here. I can see that there is a 16 here. And finally, there is a 20 here. So I have presented all these numbers, all these observations in the ascending order. Now, in this quartile deviation, I need to find out the value of the first quartile. I need to find the value of the third quartile. Okay, I want to find out the value of what is Q1 and what is Q3. What is first quartile? Very easy. N plus 1 divided by 4. That's what you should do to find the first quartile. Number of observations, it is 1, 2, 3, 4, 5, 6, 7. 7 observations are there. So 7 plus 1, 8, 8 by 4, that is equal to 2. So the second observation, it is going to be Q1. What is that second observation here? That is 9. You saw that? That is equal to 9. Okay. Now, in the same way, you can see that 3 times n plus 1 upon 4. Okay. You know that n, it is equal to 1, 2, 3, 4, 5, 6, 7. 7 is there. 7 plus 1, 8. 8 by 4. That is equal to 2. 3 2s are 6. The sixth observation, 1, 2, 3, 4, 5, 6. The sixth observation, this is going to be my third quartile. Please be here. Sixth observation, this is going to be my third quartile. So I am writing those values here. 9 is one quartile here and 16, it is the third quartile here. Okay. Now, for finding out the quartile deviation, you need to do Q3 minus Q1 divided by 2. Here it will be 16 minus 9 divided by 2. That is what you should do. 16 minus 9, it is equal to 7. 7 by 2, when you consider, that value will be equal to 3.5. So the quartile deviation for this given set of observations, it will be equal to 3.5. So the steps that you have to follow here is the given set of observations, present them in the ascending order. Locate Q1, the first quartile. Locate Q3, the third quartile. How to find the first quartile? Look at the number of observations. It is equal to 7. So go for 7 plus 1 upon 4. Okay. That is equal to 8 by 4. The second observation, which is 9. In the same way, you go for the third quartile. That will be the sixth observation. You have already arranged the observations in the ascending order. Go for that sixth one. The sixth one, it is 16. Then you find out what is that Q3 minus Q1 upon 2. 16 minus 9 upon 2. We can see that. And there we go. Q3 minus Q1 by 2. 16 minus 9. That is 7. 7 by 2 when you do. 3.5 you will get. And that is the quartile deviation here. Okay. So with this, we have reached the 16th question, okay, in this lot. Now, let us consider the next question. Here you are asked to find the mean deviation of this given set of observations. So, how to find out the mean deviation? What is the basic formula? So that I shall just present in front of you. So to find the mean deviation, this is what you have to consider. Okay, so just a second. Here we go. I'll just paste it here, okay, the table. So this is the formula. Just have a look at it. Okay, so step number 1, you need to find the arithmetic mean of this given set of observations. Since it is just a deviation, no need to arrange them in the ascending or the descending order. So you keep adding the numbers. 1 plus 11, it is equal to 12. 12 plus 13, it is 25. 25 plus 5, it is 30. Let it be there. Then you have 17 plus 7, that is equal to 24. Okay. 24 plus 16, that is 40. 40 plus 30, 70 plus 2. You can see the total comes as 72. I don't know how many of you saw the way I added the numbers. Okay. First, I added 1, 11, 13, and 5. I got the total as 30. 17 plus 7, 24, plus 16, 40. So 40 plus 30 is 70, plus 2, 72. So the total, it is 72. So the arithmetic mean when I consider, that is equal to 72 by 8. And I can see that it is equal to 9. The arithmetic mean is 9. Now the next step is, you find out from this arithmetic mean how much 1 is deviated, 11 is deviated, 13 is deviated, 5 is deviated. That's what it is mentioned here. You find the modulus value, the absolute value of individual deviations. Don't consider it as positive or negative. Okay, just to how much 1 is deviated from 9. 1 is deviated from 9 by 8 points. 11 from 9, 2 points. 13 from 9, it is 4 points. 5 from 9, it is 4 points. Okay, 7 from 9, 2 points. 2 from 9, it is 7 points. 16 from 9, it is by 7 points. Right? And 17 from 9, it is by how many points? 17 from 9, 8 points, right? So 9 plus 8 is 17, 9 plus 7, it is equal to 16. 9 and 7. From 2, when you consider, it is deviated by 7 points. So this is what you are getting. Okay. So the next step is you take the sum of these deviations. Take the sum of the absolute value is what you have to take. Don't go for positive or negative. Find the sum of the deviations here divided by number of observations. The number of observations we have identified that it is equal to 1, 2, 3, 4, 5, 6, 7, 8 divided by 8 is what you should do. Again, let me just see what is the total that is coming. 8 plus 2 is 10. Okay, you can say 8, 9, 10. So 20 ho gaya. 7 plus 4 is 11. 7 plus 4 is 11. So 11 plus 11, 22. 22 plus 20, 42. I can say this will be coming as 42 divided by 8. And that is equal to 5.25. Okay, so when you do this calculation, the mean deviation using the formula that I have presented. So first you have to find the arithmetic mean and find how much each observation that it is deviated from the arithmetic mean. You take the absolute value only. Okay, so you can say the total, it comes as 42, the total of all those deviations you will take. Divide that with number of observations. 42 by 8, 5.25 it comes. Option D reads 5.25. And for this particular question, I can see option D, it is going to be my final answer. Okay. So we have just completed the 17th question in this set. All right. All right, students. Let's now consider the next question. Here you are asked to find the standard deviation of A comma B. It is given that A is greater than B. Okay. So you should be familiar with the basic formula, how to find the standard deviation. Okay. So I shall share that formula with you. Just a second. The standard deviation, okay, it is also called as the root mean squared deviation. So you can consider that there are two formulae here, okay, which you can use. So both I will share. You can make a note of the same. Okay. So these are the two formulae which you can consider. Standard deviation, it is equal to root mean square. Okay, that is, you first to find the difference between that observation and the mean, the arithmetic mean. You take the square of that difference, add them together, and then you divide that with the number of observations, And then whatever the result that you are getting, you take the square root of that. Okay. So basically, the standard deviation is nothing but root mean square. So the square root of the deviation, square of the deviation from mean. Listen, square root of the arithmetic mean of square of the deviations from the mean. Root mean square deviation. That is what standard deviation it is. Okay. And also standard deviation can be calculated using this formula, square root of summation xi square upon n minus x bar square. Okay, what this is, with the help of a problem, I shall explain. But for the time being, requesting you to consider these two formulae. Okay. Now, as far as our the given question, it is concerned, let me have this value or formula here. Let it be there. The first job is to find, there are two observations, okay, A comma B. Let me find out what is the arithmetic mean. Arithmetic mean is nothing but A plus B divided by 2. Okay. So what you have to do here is, you first to find out what is this A minus A plus B divided by 2, the deviation you find out, and then you take the square of this value, plus you find out B minus A plus B divided by 2. Okay, how much B is deviated from the arithmetic mean? You take the square of that. Now, you find the arithmetic mean of these two values that you have found out. That is this square value plus this square value whole divided by 2 you find out. And then you take the square root of these observations, the values what you just calculated. This will be nothing but the standard deviation. This is the formula that you have to consider. Okay, so please make a note of this, how I have calculated it in a very simplified way. Okay, and also be aware that this 2 will be coming inside that square root. Okay, so I shall just present it in this manner in front of you. Okay, so this is nothing but our standard deviation. Okay, and please be aware that standard deviation, it is equal to square root of variance. Okay, there is another term that you should be familiar with. Standard deviation, it is equal to square root of variance. Or I can see that variance, it will be equal to standard deviation square. Okay, so interchangeably, you should be knowing it. Now, let's continue with our question here. Let us first simplify this. Okay, so what is the standard deviation? The formula I have actually written here. Now let us do the calculation step by step. Okay, so the first step is you find out what is the arithmetic mean. Now you find out what is A minus A plus B divided by 2. How much it will be? You can see that this is nothing but 2A minus B. That is nothing but A minus B by 2. That is what we have. Similarly, you find out what is B minus A plus B by 2. That is really nothing but B minus A divided by 2. So you have calculated how much these individual values, they are deviated from the arithmetic mean. So that you have taken care. Okay, now what is the next step? You find its square. Okay, you take its square. Okay, so that will be like A minus B by 2 the whole square, B minus A by 2 the whole square. So we have reached up to this point. Now what is the next step? Take this arithmetic mean of these two values. Okay, take the arithmetic mean of these two values. So how it will be looking like? Now it will be a minus b the whole square by 4 plus a minus b. B minus a the whole square is as good as a minus b the whole square. Okay, divided by 4. You find the sum of these two. Okay, squares divided by the number of observation, it is equal to 2. And how much this will now become? This will now become 2 times a minus b the whole square upon 4. That is nothing but a minus b the whole square upon 2 by 2. Okay, which upon further simplification, it will now become a minus b the whole square divided by 4. Okay, so I have done the mean square. Okay, that is square of the deviation from the arithmetic mean. Okay, that I have just finished calculating. Now, what is the final step? I am going for finding the square root of this guy. And when I do that, when I find the square root, okay, what is that I am going to get? Please note, when I do that, it will be coming here further as a minus b upon 2. This is what I will be getting. It is given that a is greater than b. So my final answer, it will be a minus b by 2. Option D, it is going to be my answer. Okay, so for everyone's understanding, the standard deviation for calculating it, first you find the arithmetic mean, which is a plus b whole divided by 2. Then you will be finding the root mean square deviation. So you take the square root symbol here. You find out what is a minus a plus b by 2, the whole square, okay, plus b minus a plus b by 2, deviation of b from the arithmetic mean, the square of that, whole divided by the number of observation, it is equal to 2. So this is how the calculation actually happens. Okay, for better clarity, you may put a bracket like this. Okay, just for a better clarity, I just put, and then you simplify it. Eventually, you will be getting the result here as a minus b divided by 2. As you know, a it is greater than b, a minus b by 2, it is calculated. Positive value you will get. Okay, option D is my answer choice. Okay, now let us consider the next question. Okay, so here we go. You are asked to find what is the variance of 7 consecutive integers. So I'm taking the consecutive integers as 1, 2, 3, 4, 5, 6, 7. 7 observations are there. So the fourth observation, it is going to be the arithmetic mean. Okay, so please be aware the arithmetic mean of these 7 consecutive integers, here, based on what I have selected, it is equal to 4. Let us find the standard deviation. Okay, so my first job is to find out how much 1 is deviated from 4. 3 units. Okay, 1 is deviated from 4, 3 units. Square of that, 9. 2 is deviated from 4, 2 units. Square of that, it is 4. 3 is deviated from 4, 1 unit. Square of that, it is 1. 4 is deviated from 4, nil. Square of that, 0. 5 is deviated from 4, 1. Square of that, it is 1. Similarly, 6 minus 4, 2. Square, it is 4. And 7 minus 4, it is equal to 3. Square, it is 9. Okay, so I have taken that. Now, let me find the arithmetic mean of these deviation squares. I can say the sum of observation divided by number of observations is 7 here. So I can say this will be 9, 10, 14. 14 plus 14, it is 28. 28 by 7. I can see that this value 28 by 7, this is equal to 4. This is what I am getting. So please note, standard deviation will be nothing but square root of this value 4, and that is equal to 2. But that is the standard deviation. What are you asked to find? You are asked to find the variance, right? So please note, variance, it will be equal to standard deviation square, and I can say it will be equal to 2 square equal to 4. So as far as this particular question it is concerned, the value, it will be equal to 4. Okay. So you take random, or I would rather say 7 consecutive integers, right? Random consecutive integers 7 in number you can take. I decided to opt for 1, 2, 3, 4, 5, 6, 7 because they are very small numbers. Okay, so it's easy for you to handle them. Okay, finding the deviation from the mean, square of that, taking the arithmetic mean of those, square of those deviations, everything will be very handy, provided you are taking numbers like this 1, 2, 3, 4, 5, 6, 7. Okay, so that is sufficient. My final answer, it is coming here as 4. The variance value, it is equal to 4. So that brings conclusion to question number 19. Now let us consider question number 20. You are considering the standard, you are asked to find the standard deviation of 18, 18, 18, 18, 18, 18, 18, 18, 18, and then a 23. Okay. So for answering this particular question, what I am going to consider, I will, just a second, take that second formula which I had presented. Okay. Just a second. See, this formula is what I will be considering. Okay. The second one. I will be using this formula for answering our question. So let's have a look at it. 18, 18, 18, 18, 18, 18, 18, 18, 18, 23. Okay. To make these numbers quite handy, what I am going to do here is, I'm going to subtract 18 from each of those observations. Then I have the observations as 0, 0, 0, 0, 0, 0, 0, 0, 0, 9 observations ho gaya, and then 23 minus 18, that is equal to 5. Got it? Now, we can consider here the standard deviation, it is equal to square root of xi square upon n minus x bar the whole square. So here I can consider summation x square. Okay, first we will find out what is the arithmetic mean of these observations. Okay, so sum of all the observations, it is equal to 5. By number of observations, it is equal to 10. So I can consider that the arithmetic mean value, it is equal to 5 upon 10. Got it? So I have that value here as 5 upon 10. Now, here I am finding 0 square plus 0 square plus 0 square. That's what sigma xi the whole square. So 0, 0, 0, 0, 0, 0, 0, 0, 0 square plus 5 square, that is equal to 25 divided by number of observations. See this 0, 0, 0, 0. I'm taking the sum. Finally, I have a 5 here. So 5 square 25 divided by number of observations, it is equal to 10 minus, the arithmetic mean is 5 by 10, the whole square. That will be nothing but 25 divided by 100. I'm going to take the square root of this guy. So now you know what this will become. This is now going to become 25 by 10 can be written as 250 by 100. So 250 minus 25, that is equal to 225. This will now become square root of 225 divided by 100. Taking the square root, it will come as 15 divided by 10, and that results in 1.5. Look at the answer choice here. We can see option D, it reads 1.5. That is going to be my answer. Okay, so for simply answering this question, what you have to do is all these observations are the same, right? So you subtract 18 from each of these observations. So these 9 18s that I have presented here, all of them will become 0. 23 minus 18, this will become 5. Now just use this formula, summation xi square. So when you consider it individual observation, 0 square plus 0 square plus 0 square plus 0 square, like that 9 times, plus 5 square, that is 25. That 25 divided by 10 you do. Okay, minus. Arithmetic mean, you know, it will be coming as 5 upon 10. Okay, that is the arithmetic mean. Take its square, that is 25 by 100. So 25 divided by 10 minus 25 divided by 100. On simplification, you have to take the square root also. The root is there, okay? So square root of this value. And you can see that ends up getting 1.5. Option D will be my answer choice. Okay. So that is giving us the explanation for the 20th question. We have got 5 more questions to go in this handout. Let us go to the next question. You are asked to find the standard deviation of x1, x2, you are given that the standard deviation of x1, x2, x3, x4, etc. up to xn, that standard deviation, you know, it is equal to 5. You are asked to find the standard deviation of 3 times x1 plus 2, 3 times x2 plus 2, 3 times x3 plus 2, etc. 3 times xn plus 2. How much is that? If you observe carefully in this question, you know, if you add or subtract a constant number from the given set of observations, the standard deviation value, it is not going to get affected. Did you see that? Here 18 I subtracted, right? So finally I had 23 minus 18, I got it as 5. Constant number only I subtracted from each and every single observation. Standard deviation didn't change. The standard deviation of this guy and the standard deviation of this guy, it is actually one and the same. Okay, so same logic when I consider here, this plus 2, what I have presented here, it is not going to have any impact on standard deviation. But you have 3 times x1, 3 times x2, 3 times x3, making it 3 times, okay, that is going to have an impact on standard deviation. If the given standard deviation for these set of observations, you know, it is considered as 5, then when you change the value 3 times the original number plus 2, like that when you are doing, you can see that the standard deviation now it will become 5 into 3. That is, the previous standard deviation will also become 3 times like what you see here. So 5 into 3, you can consider that 15. That is going to be that revised standard deviation. So for this question number 21, my answer, it is equal to 15. Okay, that individual addition or subtraction that you are going to do for each and every term is not going to affect the standard deviation. But when you have a multiplication factor over there, same will be getting reflected on that standard deviation I have presented. Okay, so please make a note of that. 15 is going to be my answer. Okay, let's consider the next one. It is given the sum of the cubes of the first n positive integers is 3025. You are asked to find the arithmetic mean of these cubes. So here, sum of observations is given to you. Number of observations you don't know. That you have to find out. So you very well know that sigma n cube, sum of cubes of first n positive integers, is given as n into n plus 1 by 2, the whole square, right? And that is given as 3025. Okay, kindly recall, sigma n cube is n into n plus 1 by 2, the whole square. This value is given as 3025. So from this, can I not say n into n plus 1 by 2? That is going to be square root of 3025. What is square root of 3025? That is equal to 55. So this fetches the result n into n plus 1. That is equal to 55 into 2, which is 110. Product of two consecutive numbers, you are getting it as 110. A little bit of observation will help you to understand that this n, it is equal to 10. So that you can see 10 into 10 plus 1, 11. It is coming as 110. See, a little bit of observation. Okay, and mathematical skill, you can use it and say that the number of observations, it is equal to 10 here. Now, the entire question, it changes that tone. See this. The sum of the cubes of the first 10 positive integers is 3025. So you got the number of observations. You're asked to find the arithmetic mean of these cubes. What is that arithmetic mean? Arithmetic mean is sum of observations divided by number of observations. I can say my answer will be 302.5. Looking at the options, I can say option D, it reads 302.5. So the answer for that 21st question, I can say it will be option D. 300 and, the answer for question number 22, I meant, it is 302.5. We have just completed the 22nd question. Okay, 302.5, option D. Okay, so it's all about finding the number of terms, which I could see it is equal to 10. Now, 3 more questions to go. Let us have a look at this question. The algebraic sum of the deviations of 10 numbers taken about 7, it is 40. What is the arithmetic mean of these numbers? Okay, let us consider that the original numbers are A, B, C, D, E, F, G, H, I, and J. It is given that 10 numbers are there. So these are those 10 numbers, the original 10 numbers. Okay. Now, what you are doing here is you are taking the algebraic sum of the deviations of these from 7. So I am considering something like A minus 7, B minus 7, C minus 7, D minus 7, okay, E minus 7, F minus 7, G minus 7, H minus 7, I minus 7, and J minus 7. Okay, you can see that this sum of these individual deviations that I am going to consider. See, this sum of these individual deviations of these numbers from this number 7, when I am considering, it is given in the question that it is equal to 40. Got it? So you can see that this minus 7, you are doing it 10 times here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these are minus 7. Okay. So can I not consider that this is nothing but A, B, C, D, etc. up to J minus 70, and that is equal to this 40. Okay. So will this not give me the result A plus B plus C plus D plus etc. up to J? This value will be coming here as 70 plus 40, that is equal to 110. So I got the sum of the original sum of all these observations. I can say that is equal to 110. But the question is not about what is this sum. The question is about the arithmetic mean of these numbers. Okay, not the deviated numbers, but the arithmetic mean of these numbers, how much it is. So I know the sum of observations is 110. Number of observations, it is 10. So I can thus see that the arithmetic mean value, it will be coming here as 11. Got it? So that is for this particular question. 11 is my final answer. Okay. Now we have got 2 very easy questions to be answered. Look at this. The geometric mean of 2 positive numbers is G. Harmonic mean it is H. Arithmetic mean it is A. How these 3 are related. Okay. So I can see that G, it is equal to root xy. It is given that H, it is equal to 2xy by x plus y, and you can see that a, it is equal to x plus y upon 2. Okay, we already know that g square, it is equal to a into h. Geometric mean square, it is equal to arithmetic mean into harmonic mean. We can validate it also. G is root xy. So what is g square? G square is xy. It is equal to a, which is x plus y by 2 times h. H, it is nothing but 2xy by x plus y. Got it? Now we can see that here this x plus y can be cancelled. This 2 can also be cancelled. You end up seeing xy is equal to xy. I can see that LHS it is equal to RHS, hence proved. So for this particular question, option A, g square, it is equal to a into h. That is going to be my final answer. Okay. And now the final question, it is given a, it is equal to max of x comma minus x. Okay, for example, let me take at x equal to 5, let me take. So I can see that a, it will be nothing but maximum value among 5 and minus 5. What is that? The maximum value among 5 and minus 5, you know, it is 5. And B, it is the minimum among this 5 and minus 5. You know, that is equal to minus 5. Okay. Therefore, the arithmetic mean of A and B, that is A plus B by 2 when I do, I can see that in this case, it is coming as 0. So this is the case, you know, when you are considering x, it is equal to a positive number 5. In the similar way, we can even consider what is going to happen with a negative value. Say at x it is equal to minus 10. See what is happening. A, it is nothing but maximum among minus 10 and 10. Got it? Maximum among this considered value and the negative of that value. How much it comes to? You can see that among minus 10 and 10, the maximum value, it is equal to 10. Okay, similarly, B, it is nothing but minimum value among minus 10 and 10. And you know, that is nothing but minus 10. Here also, when you are going to take the arithmetic mean, that is A plus B by 2, you can see that value is coming as 0. Okay, so whether this x that you are considering it is positive or x that you consider which is negative, either way around, you can see that by going with that maximum and minimum this condition, the arithmetic mean of A and B, that is A plus B by 2, invariably in both these situations, you know, the value it is equal to 0. So for this particular question, I can see my final answer, it will be coming here as 0. Okay, so with this, we have reached the end of our lecture, this discussion. So we have completed this topic, that is statistics. Okay, so like I said in the beginning, we have learned two aspects here. The first one, it was the measure of central tendency. And then we also considered the concepts related to this measures of dispersion. Measure of central tendency, when we are considering, we can see that it is mean, median, and mode. And in mean, we saw AM, GM, and HM, then median and mode. And measures of dispersion, we talked about range, quartile deviation, mean deviation, standard deviation, and also we talked about the variance. So please learn well properly all these concepts and solve more questions for a better understanding and clarity of the concepts. And with this, I am concluding this video lecture. Okay. Thank you and take care.